called Derivco out of South Africa, Durban, the east coast, the Pacific, sorry, not the Pacific Ocean, but the Indian Ocean of South Africa. I just spoke to John here and saying that right now we have the cold, so it's winter down here now. We have the coldest winter we've had for a long time. So in the mornings it's like 8-9 degrees plus. During mid of the day it is below 20, 18, 19, and that is cold for Durban, and we are all wearing sweaters and stuff. So yeah, anyway, it's interesting. So I work for a company called Derivco. We are doing software for online gambling. In Leeds, I know you have a couple of companies, Bet365 and Skybet, I think they are called, that are doing something similar. But yeah, so that's what we do. I'm also a data platform MVP, so most valuable professional, whatever it is called. Yeah, that's kind of me. You have my contact details, so questions, comments, whatever. Please feel free to ping me. Yeah, that's about it. So, right. So before we dive into it, or rather, this is the agenda. So we'll start talking about Kafka. So basic introduction to Kafka 101. We'll then talk a little bit about Kafka and .NET. And as John said, back in the day, the .NET support for Kafka was not the greatest. It was lagging behind the sort of the Kafka client made in Java. That has changed quite a lot now. We'll talk about that a bit. Having then looked at how you would implement some Kafka stuff in .NET, we'll start talking about stream processing, what stream processing is, how you do stream processing, and when we're talking about stream processing, we'll definitely by default we'll talk about something called ksqlDB. So ksql is the, call it, language for stream processing in Kafka, and recently, a year and a half ago, they introduced this thing called ksqlDB, which is like an event-driven database-like thing. It is not the database per se, but we can see it as a database. So that's kind of what we're going to talk about today. Before we do that, before we dive in, let's talk about data. So I'm a database nerd. I've been working with databases since the dinosaurs almost. So data is something that is near and dear to my heart. I have some statements here around data, and I'll come back to why I'm doing this in a second. So civilization has always run on data, and if we think about it, I mean, when Moses came down with the tablets, well, not the iPad, but his stone tablets, that was data. He had something inscribed on those. That's data. And right now, we all know that whatever we do today in today's world, that is based on data that is fueled by data. We are being marketed based upon data that we are leaving behind in whatever way it is, like if we're Googling something or if we're filling in some form or whatever. That is data that is being used for us, to us. Oil, I mean, so we have resources, and oil is a resource, but oil is not renewable. We do know. We do know that one day we will definitely run out of oil. Whereas data is always being renewed. We are always get new data. We get more data, and even if we run out of oil, data will still be there. And we're then coming down to this, that when we are getting economical bad times, the data still continues to grow. So we had COVID. I mean, we've had COVID now for a year and a half, but there is no less data now, or no less data has been produced than what it was before COVID. Right? All these statements are coming from a book by Brad Smith. The book is called Tools and Weapons: The Promise and the Peril of the Digital Age. So since we are since the user group is a Microsoft user group, I assume that you all can tell me who Brad Smith is. If you can't, so he is the lead. He is the lead counselor for Microsoft. So he's been with he was with Bill Gates, and now he's with Satya. And he wrote this book, and if you're interested in data, if you're interested in what Microsoft has been doing, if you're interested in Azure, the cloud, go and get that book. It is really, really good. If we're talking a little bit more about data, and we're saying that how data is always growing. So in 2016, we had around 16, research has shown, I have no idea how they done this research, but research has shown that we have around 16 zettabytes of data. And a zettabyte, it's a lot. It's a billion gigabytes, I think it is. So that's a lot of data. So that was 2016. In 10 years' time, or 9 years' time, we estimate that we will have 165 zettabytes worth of data. So it's a tenfold increase in 9 years. So this just shows, this proves these statements above, that this is, everything we do is about data. And why am I going on about this? Well, we are here to talk about Kafka, but what does Kafka do? Well, we are publishing data, we are consuming data. And what I'm saying in other talks is that if we do not handle that data, if we don't do anything with that data, we will soon, the competition will overtake us. The competition will use the data. So it is extremely important that we can handle the data and get the most out of the data. And that's where Kafka can come in and help us. And that's what we'll look at here and now. Cool. So if you have questions, comments, please shout out or write in the chat or whatever. Right, so Kafka 101, what is Kafka? So it's not the author, it's not the writer, but Kafka is a kind of message broker. Let's call it a message broker to begin with. We will soon see that it is much more than a message broker. But Kafka started back at LinkedIn back in 2009, 2010. And in 2014, it was open sourced, still by the guys and girls that developed it at LinkedIn. And shortly thereafter, these guys, Jay Krebs, etc., they founded Confluent, the company Confluent, which is the commercial arm of Kafka. So Kafka is absolutely open source. But as with a lot of recent technologies, recent open source technologies, there will also be a commercial and enterprise part of that. And Confluent is sort of the company that provides an enterprise version of Kafka, or rather provides enterprise support for Kafka. Kafka is a distributed streaming platform, and with that I mean that we are publishing and consuming streams of records, where a record is an event, is a message. What is cool with Kafka is that by default the messages, the events, they are persisted. They are persisted to disk. If we're looking at other messaging systems, such as RabbitMQ, which I have worked with quite a bit, I have worked with it rather, by default, messages are not persisted. And then by having persisted messages, well, that means we can always get messages back. We can always go back in time and find messages. And being a distributed streaming platform, and what we're going to talk about today is that we can now then process. So messages are coming in, events are coming in. We now have the platform allows us to process these events in near real time. What Kafka really is a commit log. It is a log of messages coming in. They are being persisted to disk, and we can read them from disk. And why this being a commit log is a good thing is that, well, since I'm a database nerd, a database guy, transaction logs are good. They are trustworthy because we know if it is in the transaction log, then it has happened. And we have the ability, so this log now, we have the ability to distribute it across multiple boxes, across multiple machines. And by doing that, we are achieving both scale, we can scale out doing this way, and we are also achieving resilience. So if one box goes down, it's not the end of the world. We have more boxes where we have this data. Cool. Questions so far? We're good. Cool. So let's have a look at Kafka versus message queues, where, sorry guys, where in a message queue, such as RabbitMQ, for example, we have a producer here to the left, right? He produces messages. It ends up in this queue here. Let's call this a message queue. And we have multiple messages, message 1, message 2, message 3, message 4, etc. When the behavior of a message queue is that if I consume from the queue, I am reading off the message disappears from the queue. So I have consumer 1 here that reads a message, he gets message 1. Consumer 2 reads a message and may get message 2. Consumer 1 continues reading, he will get message 3, etc., etc., etc. And that means that I can only have, on a given queue, I can only have one consumer. Otherwise, I would get, I would miss messages. So in a typical message queue scenario, if you want to have multiple consumers consuming the same message, you would need to create a new queue, and the messages would sort of be copied onto that queue, and now consumer 1 can read from this particular queue and consumer 2 can read from this queue. So in essence, we will now duplicate the messages, they will take more space, etc., etc. So that is one of the big issues with, well, not big issues, but that is a difference to how Kafka handles things, because in Kafka, the messages ends up in, let's call it a queue for now. We will soon look at what it is called. It ends up in this queue, and the consumers, they are reading based upon an offset. So consumer 1, he has been quite active, and he has consumed from message 1, message 2, message 3, and he now consumes message 4. Consumer 2 came in a little bit later, perhaps started up a little bit later, and has consumed message 1, and are now about to consume message 2, excuse me, whereas consumer 3 has just started up, and he is now consuming the first message in the queue, if that makes sense. So from a Kafka perspective, I can have multiple consumers consuming from the same queue without the messages disappearing. So when I read a message here in Kafka, when I read a message when consumer 1 is now reading message 4, that message will, after he has read it, the message will still be there. So that when consumer 2 comes along, message 4 is still there and can be read by consumer 2, if that makes sense. So, key concepts of Kafka. We're talking about the cluster, and I mean, we are all computer people, so we know what a cluster is. A cluster is one or more machines, and that are somewhat related to each other. And in a Kafka cluster, we have one or more brokers. Right? So in Kafka, we're saying we are always talking about the Kafka cluster, and we're talking about the Kafka broker. The cluster can quite easily consist of just one broker. That's not a problem. It is still a cluster, even you have just one box being the broker. We have topics, we have partitions, we have offsets, and we have consumer groups, and we'll have a look at that right now. So topics and partitions. So a topic in Kafka is a little bit, well, it is like a database table. It's a name. A database table has a name. A topic has a name, and that defines now a stream of message records, events, whatever it is. Exactly as you in a database table, you have rows of data. The same thing for a topic. You have multiple events, records, once again, call it whatever, in this topic, and they are most likely defined by they are defined by a name. So in my world, so as I come from an online gambling company, we're talking about wagers, we're talking about logins, we're talking about orders. In a banking world, we may have credit card authorizations, for example, or if I'm like Visa or MasterCard, I have a topic for credit card authorizations. This topic has a schema. It can be JSON, it can be Avro, it can be CSV, or it can be protobuf. Most likely, at least when you start up, you probably are using a JSON schema. The record then, the event, the message that is being passed into the topic is defined by a key, and that is a little bit like a primary key in a database table. It has a value and it has a timestamp. So when a message comes into a topic, it will be timestamped, unless you as a producer has already given it a timestamp. But if you don't give it a timestamp, excuse me, then the broker will assign a timestamp to it. And then the topic has various properties, like how long should we keep the message here? Is it compressed? If it is compressed, what is the type of compression? How many partitions it has, and a replication factor. And we'll talk about, so a replication factor is if I have multiple brokers in my cluster, how many brokers will this message exist on? So if I have a 5 broker cluster and I have a replication factor of 3, any given message will end up on 3 of these brokers. Number of partitions. And so here is kind of just an example where we see we have my cluster here. We have 3 boxes, box 1, box 2, box 3, and we have topic 1 is across 3 brokers. Topic 2 is across 3 brokers. Right. So properties, I said that as a property of a topic is a partition, and the partition is basically the most important part in a topic, because through the partition we can ensure that messages are being handled in order, and we are getting scalability and parallelism, etc. So when I publish a message to a topic, it ends up on the topic, but it actually ends up on a partition in that topic, where the partition is the log. That's kind of the log file. That's where the message eventually ends up. And you, as a publisher, you control the partitioning, and you you control it by assigning the message a key to the message, right? So we said here how the message has a key, i.e. the primary key, and it is the key that defines where the which partition the message will end up on. You as a publisher, you don't need to tell Kafka that it should end up on this particular partition, but you are telling Kafka what is the key for this message, and then through some hashing of the key and a modulus operation against the number of partitions, the message will then be placed on a particular partition, if that makes sense. Right. And the messages then ends up on the partition with an offset. So the first message will end up in an offset of 0, second message will end up in an offset of 1, etc., etc. And these offsets are unique per partition, per topic. And then as a consumer, I use this offset to say, where do I want to consume from? Earliest, latest, or at a particular offset. And now by the fact, so I said 1 or 2 slides ago that we are not reading off, when we are reading the message, we are not reading it off the topic. It doesn't disappear. It still sits at the topic in the partition until until the retention period is up and it is deleted. But by the fact that it sits there, it is retained, and by the fact that the message has an offset, I can now go back and replay data. So let's say that during my consumption, something goes bad. I'm crashing, burning, things goes bad. I have the ability to go back to the last read proper offset that I had and reread the messages. And that is a huge, huge, huge advantage for Kafka. And that is one of the main reasons why we at Derivco, we switched from using RabbitMQ to Kafka as a message, as an event streaming platform. Questions so far? Are we good?
Good for me, Niels. Thanks.
Okay. Cool. So the question is then, how do I get scalability, and how do I get ordering from a consumer perspective, right? And we are doing that by something called consumer groups. We are saying So in Kafka, a consumer, a client, a consumer can only read. Let me rephrase it. A topic has one or more partitions, and a consumer can only a partition can only have one consumer. So I can only have one, let's say, executable reading from a partition in a Kafka topic, from one or more partitions in a Kafka topic. And now you then may ask, but how in earth name can this be scalable? How do I get performance? How do I get this, that, and the other? Well, the answer is that it is not the executable, it's not the actual application per se, but when we are creating a consumer, we are saying that this consumer, this client, belongs to a consumer group. And I can only have one consumer group, one instance of a consumer group reading from one or more partitions on a topic. So I can have 15 consumer groups, and they can all read from the same topic and partition, for example. And so as we say here on the slide, that only one reader from one consumer group allowed to read from a partition or from multiple partitions. So if we look at this slide, so we have here a broker, or we have a cluster, it doesn't really matter, with two topics, topic A and topic B. Topic A has 3 partitions, 1, 2, and 3, and topic B has one partition, partition 0, 1. Yeah, I wonder why I didn't call that partition 1, but anyway, it doesn't really matter. So we have now here a consumer group that we called group A. Right. So we have we have a client that consumes messages from Kafka. We have given it the name group A, and I now have within this, within this, let's say that we have 3 executables: C1, C2, C3, all having the name group A. Right. So C1 reads from partition 1 of topic A. No one else from this group can read from that partition. Right. C2 reads from partition 3 from that topic, and it also reads from partition 0 of topic B. So a consumer in a consumer group can read from multiple topics. That's not a problem. C3 reads from partition 2. Right? In the consumer group B, C5 reads from topic B, partition 0, and C4 just sits idle because we already have a reader for topic B, partition 0. So you can never have a consumer group, can never have more consumer instances than there are partitions for a topic. So now in this example up here, if we added a 4th consumer, C4, and we wanted C4 to consume from topic A, he would just sit idle. He or she would just sit idle because we already have 3 consumers consuming from topic A, if that makes sense. The examples of this in a little bit. Right. So, questions about that? No? Clear as mud. We have topics and we have partitions. And if you're, once again, if you're a DB guy or girl, think about topic as a table, and think about partition as a partition of a table, or potentially a sharded table across multiple databases. That's kind of the easiest way to think about it. So now then, so we have a Kafka broker. Actually, let's have a look at that. So I have here somewhere. So I have installed, or well, I haven't installed, but I have, come on, where are you? Let's do it this way then. So I'm running Kafka in a, sorry, John, you're seeing yourself. I'm running Kafka. I'm running Confluent Kafka. So this is the enterprise version of Confluent. If you're running in a one broker setup, you can run Confluent Kafka for free, the enterprise version, and that's what I have here. So I have one broker, and this is it comes with the nice thing here with Confluent Kafka is it comes with a nice web UI where it sits on port 9021 on the broker you have it installed on. Right. So if we're looking here, getting into a cluster overview, we can see with brokers. I only have one particular broker at the moment with a broker ID of 1. And if we look at topics, so this is a completely new Docker compose up command. So nothing has been done with this broker yet. And the only topics I see are some system topics that always is there. So let's actually create 2 topics. So we're adding a topic, and we're calling it test, because that is the law. If you're creating your first topic, it always has to be called test topic. Not really, but let's assume that is the case. So here I now have the ability to set however many partitions I want. And in a production environment, you probably should think about the load that will come into this topic, and so how many messages, etc., and how they are distributed, and then create as many partitions as you think you would need. Right. And for me, I'm happy with one partition for now. So we're creating we now have a test topic here, one partition, nothing has happened here yet. Let's create a second topic, because I spoke about this credit card company. So we also want a topic called card auth, for card authorization, and we will use it a little bit later on, but I'll do it now so I don't forget to do it. Right, so we're creating that also with one partition. Cool. Now then, so now we have a broker, we have some stuff. So Kafka was originally, well, it is still, but written in Scala, and there is a native. So initially it was pure Scala, then Java came into the picture as well, and the client now to consume or publish to Kafka, we have a native Java client that has all the bells and whistles. And as John said earlier, and as I alluded to, that initially, so we've had a .NET client for quite a while. Initially, that .NET client was really not up to par with the Scala/Java client. that has now changed since version 1, I think. Anyway, so we have the native Java Scala Java client. For other languages, the Apache Foundation has created this C implementation called librd Kafka, which kind of gives us the same ability as the Java client has, and other languages now, such as .NET, such as Python, such as Go, Rust, whatever, are written on top of this librd Kafka implementation. The latest version, well, quite a few since a year or two, the .NET client is now on par with the Java client, just because it uses an librd Kafka version that is on par with the Scala Java client. Cool. So to use this then, let's see if we can do that. So to do that then, let's make so what we want to do is we want to create an application that publishes to Kafka. Let's just see what we have here. Ooh, okay, so let's do this. Make directory test2. So after a webinar like this, after a session like this, I have, I don't know how many directories called tests. So I start with test, doing test 1, test 2, test 3, test 4. So let's create a library called test2. So let's cd into that, and then spin up Visual Studio Code. As I trust the authors, I probably shouldn't do that, but anyway. Right, cool. So we are now in my test2 library. We don't really have anything here whatsoever. Let's spin up the terminal. And now what we want to do is we want to add the Kafka client. So come on. Why isn't that working for? There we go. So we are creating a new configuration here. We're setting the topic. We are creating my producer. And we are calling produce async, and we are getting in here, we should see, right, that we deliver test to test topic 6. To if we then go back to control center, in my topics, looking at test topic, so the later versions of this web UI allows you to go in and look at the topic and see messages in the topic. So we are jumping to offset 0. Now we say read from this topic. So actually, so we're saying offset 0, partition 0. Right? So we're saying there, and now here we are. Here we now have that message that I just sent. the event, the record, call it whatever. We don't have a key. A key is null, value is test, and here is that timestamp that I spoke about. So this is a Unix time. This is an epoch time. So now we have this message here. That's cool. Right. So let's go back to here just a second. So we did that, and here we have the produce code. Do we have any questions around that so far?
There's one question from Adrian in the chat. Can Kafka behave like a messaging queue, i.e. you have multiple consumers on one topic and the message is only read by one consumer?
Can Kafka behave like a messaging queue? You have multiple consumers on one topic and a message is only read by one consumer. Yeah. I mean, why? Okay, so my question is, why would you have multiple consumers on one topic? If you only want a message to be read by one consumer only.
Is that like competing consumers model, where you want it like multiple processes of one queue? Is that
so?
What
Are you so? Do you want sort of a round robin, where consumer one reads one message, consumer two reads next message?
Yes.
Why? So no, you can't. You don't have that. You don't have that scenario. You cannot round robin from one consumer group. You cannot round robin or multiple consumer groups for that matter. You cannot round robin messages on the topic. Like you can with Rabbit, for example. My question, which we can take offline, or if you ping me after this, the question is, why would you like to do that? Is my question. There may be reasons why you would like to do it, but we can take that offline. So the straight answer here is no, you can't round robin reading of messages from the topic.
Thank you. Just really helped my understanding of what it was and the differences.
So once again, the cool thing with, well, the interesting thing with Kafka is that so if you are used to, for example, RabbitMQ, right, you are publishing to an exchange, and if you want to consume messages from that exchange, you are binding a queue to the exchange, and you can have then multiple consumers binding the same queue, in which case you then get a round robin consumption, but you are kind of losing the context of the message, essentially, right? So message one has a value of 100, message two has a value of 200, and you really now should have an aggregate value of 300, but message consumer one gets message one, consumer two gets message two, and you have lost context. But if that's what if you don't need the context, yeah, that's probably a way to do it, absolutely. However, if you now in a RabbitMQ scenario want consumer one and consumer two to get the same messages. So back in the day, well, a couple of years ago at Derivco when we were using RabbitMQ for message processing, and we had multiple systems using reading off the queue. What we had to do, well, what you have to do in the Rabbit world is to the consumer 1 binds a queue, consumer 2 binds another queue, and now both queues are getting the message, but the message is now copied. The message is duplicated between these two queues. Whereas in the Kafka land, you just have another consumer group that reads against the topic, if that makes sense. Other questions? Cool. And I am actually, so it sounds like I'm bashing Rabbit here. I'm not in any shape or form. Rabbit is extremely good, and Kafka is extremely good. It's just a little bit different ways of doing things. I like Rabbit a lot. Cool. So now we have a publisher. Let's see if we can have a consumer. So instead of me coding this up from the from scratch, which is always painful. Let's see what we, so I have here a pre-created consumer. So a little bit like the same as I'm doing with a publisher, I'm creating a config, consumer config. I am assigning it a group ID. So this is now the consumer group, right? And this is just a text. This is just a name. It's just a string. It doesn't really mean anything, apart from the fact that if I have two executables or two threads or whatever that is running this particular code, if I have two partitions, I can only have two instances of this code running with the same group ID. If I have only one partition, as I have in this case, I can only have one instance running with this group ID. If I have more than one, nothing will really happen. It will the second instance will just sit idling. So cool. We're creating a configuration, the group ID. We're saying what the Bootstrap server is. We know that already, and we're saying, okay, what is the auto offset reset? So when I'm resetting this, where should I go to? And this is now saying go to the earliest offset that we have. We want to read this test topic. We're creating cancellation token source. I mean, that's in your normal .NET Core cancellation token. I'm creating a new consumer. I'm saying subscribe to the topic, and then I'm saying consume. Yeah, and I'm then saying, okay, I have consumed this message from this offset. Cool. So let's run this. Let's run this. Just build it. .NET. So setting to creating a source consumer builder, we're saying subscribe, and we're saying consume, and so here we consume the message test at test topic 0 partition 0. Right, and And now we are sitting here waiting for another message and another message and another message, right? So now we have created in .NET Core a publisher and a consumer, and it's actually not much to it, right? It's quite easy, I would say. And if we're looking, let's go back to now my control center and go to here, just refresh, test topic, and we can see that even if I consume the message, it still sits in the topic, and it will sit in the topic until the retention period is gone. Yeah. So that's kind of a very quick overview of Kafka and .NET. Any questions about that so far?
I just have one on.
No?
Oh, hang on. Adrian's got a question.
Yeah.
When did you set the retention period?
Okay, so you're setting the where did I set the retention period? I didn't. So that is being it gets a default when you're creating a topic. You're getting a default retention period. And I believe, if I remember correctly, that the default retention period is 7 days. But you can, when you're creating a topic, you can, if you want to, set a retention period. So that is completely customizable. So Kafka is extremely customizable in what knobs and levers to turn and pull and push and stuff to get the bestest performance out of Kafka. That in itself is really well, that's a topic for another talk. But yeah, so you can set all that. How many replicas do you want, the retention period, how many partitions you want, etc., etc.
So I have a question, Niels. So implicit in all of this is a piece of infrastructure running in the background to run your Kafka instance. Can you recommend any Kafka as a service providers?
Okay, so right, so up until a year, 2 years, 3 years, some years ago, up until some years ago, Kafka only was running sort of on-prem. You installed it, you ran it, you managed it, you handled it, right? In 2018, 2019, Confluent released Confluent Cloud, where it now runs as where you now have the ability to run Kafka as a service in the cloud. And you can run Kafka, it's called Confluent Cloud. You can run it in AWS, you can run it in Google, you can run it in Azure. In addition to that, AWS has its own homegrown version of Kafka called Kinesis. And in the Azure world, you have something similar where it is called event hubs. It's kind of the same semantics. It's the same, you're having topics, you're having partitions, etc. So Kafka as a service, Confluent Cloud, GCP, AWS, Azure.
That's great, thanks.
Sure. Rob, is there a simple canonical application use case for Kafka? Well, send messages, publish a message and consume a message would be my answer. So that's the canonical application. But we will now see how we can do stream processing for Kafka, and that's really so Kafka is used a lot in the microservices world, to have decoupled microservices, to do event-based processing, to do event-based applications. So you have your you have an order being pushed from the client into a Kafka topic. You have an order service listening to that, consuming from that topic, doing some stuff with the data, and when it's done some stuff with the data, push it to another topic where maybe a stock service looks it up to see, okay, do I have this in stock, etc., etc., etc. So in Derivco, we used it for an application where we, as a data pipeline, something comes in, we're taking that, we are doing some enrichment of the data, we push it to another topic where we have a service picking it up, doing some more stuff with it, etc., etc. I wouldn't call that a canonical application use case, but there are certain use cases for Kafka. Right. Cool. So we have seen the publisher, we have seen the consumer, and as you see, this is not much to it. Right, stream processing. This is now the interesting part. So I mean, sending messages and consuming messages, that's cool. But yeah, what do you do now, right? What? And I guess that's a little bit where Rob's question comes from. And what we do is stream processing. So stream processing is what we do when we want to handle events. So we see here now how the dude down in the right-hand corner here, he is pushing boxes into a conveyor belt. And in here, this guy, he decides where should green boxes, blue boxes, and red boxes go. And that's kind of example of a stream processing. That data comes in, and based upon the data, we are doing different things with the data. So an example here is that we're a credit card company, and we are interested, and when we're using a credit card, we're trying to, there are authorization attempts. And based upon these authorization attempts, we want to catch possible fraud, right? This is an excellent example of a stream processing application. So when someone swipes the card on the machine, we're pushing an event message to a Kafka queue, and then we are consuming that event from the Kafka queue to determine, is this fraud or not, or is it possible fraud or not, right? And possible fraud in this case is when we have more than 3 authorization attempts for the same card ID within X minutes, seconds, what have you. I mean, that's easy peasy, right? We have seen how we can publish events and we can consume events. But what now becomes somewhat convoluted is, how do we now implement this? How do we implement stream processing? What do we do? Well, we have the publishing part is easy. We can do that. We've seen that. That's not an issue. How do I handle the consumption part and determining whether this is fraud or not? Well, I mean, we are all awesome .NET programmers, awesome .NET developers. Well, except for me, but all you guys are awesome .NET developers. We could potentially roll our own stream processing by using the Kafka consumer that we just saw. The problem with that is, well, it's manifold. How do I handle state? Because now all of a sudden, I need to be able to handle state. I need to know that this is now the 3rd attempts for this card, and it happened within X time frame from that first attempt. right? We can use, okay, so that's probably out. I am lazy, I don't want to do that. We have something called K-streams. And K-streams, so stands for Kafka Streams, strangely enough. It was introduced 2016. And as I say here on the slide, it's a library for building streaming applications. And streaming applications where we are taking stuff from one topic and puts it onto another topic. And in between there, we do cool stuff. We do stateful stuff. The problem with K-streams is that this is Scala and Java only. So if we don't like Scala Java, then we are kind of out of luck. There has been attempts to create so the K-streams is essentially only some API calls. It's some interfaces and API calls. There has been attempts to port this to the .NET world. There exists a couple of implementations of this, but they are not fully fledged. They are just more POC versions of this. So yeah, if we don't want to use Scala Java, then we are out of luck on that one. Now it becomes interesting because in 20s, and this whole K-streams is based upon a DSL on top of some very deep plumbing in Kafka. In 2017, we introduced Kafka introduced something called ksql, which is built on top of K-streams. And well, that is a DSL where you are writing SQL syntax. As I said, we are all database developers at heart. Everyone knows select star from. So we are writing SQL syntax to achieve the same thing we do with K-streams. It is not a one-to-one parity, but it is very, very close. And you can do almost everything you can do in K-streams. You can almost do everything in ksql as well. So in 2019, Confluent introduced ksqlDB, which is an event, looks like a database, but it is on top of Kafka and Kafka topics. And through ksqlDB, you are building, once again, stream processing applications. And this whole ksqlDB and ksql, for that matter, lowers the bar to implement streaming. And so here's just an example where we want to, somewhere along the line, when we are pushing payments into a topic, we are assigning a fraud probability property. And now in ksql, if I want to know if this is probable fraud, in ksqlDB, I'm creating a stream where I'm selecting from a payments topic where fraud probability is greater than 0.8. Right? SQL, easy peasy. If I were to do it with Kafka streams, it would look something like this. Creating some new config, we're setting IDs, bootstrap servers, creating a stream builder, etc., etc., etc. And this is, this may not be that difficult, but if we're comparing this with that, I mean, I know what I would like to write. Right. So when we're saying that we lower the bar for streaming, we're seeing something like this, that Kafka streams is for Scala, Java, Scala developers. Then for the rest of the world that don't use Java, Scala, that uses .NET, that uses Go, we can use ksqlDB. If I'm a data engineer, an architect, DevOps, etc., I can use ksqlDB, and even a BI analyst that is somewhat used to write SQL statements can use ksqlDB. So ksqlDB opens, I mean, a lot of opens this whole thing up for a lot of people, which is very, very cool. When we're talking about ksqlDB, we're talking about streams and tables. Stream is it says here unbounded sequence of structured data events. So those are a stream is the messages that are coming into a topic. But what we are doing is that we are creating, when we deal with this, we have a topic and we are creating a stream on top of that topic. And then we have the ability to create, and this stream is immutable. I cannot change any data in the stream, but I can also create a table, which I can use, for example, for aggregations, etc. And the table is mutable. So I can update a table, or automatically a table can be updated with the latest state. And we're talking about a stream and table duality, where we can turn a stream into a table, or we can turn a table into a stream. But we can, that's also a topic, pun intended. That's a topic for another talk. So the ksqlDB syntax is somewhat similar to ANSYS SQL. We are creating a stream or a table, we are inserting, we are selecting, we have functions that are scalar, we can do aggregates, we have table functions, we have window functions, time-based functions. Actually, we are running really late because I have a way of speaking way too much. Can we go on a little bit longer and I can show some code? John, is that okay?
Yeah, that's fine. I mean, if people want to drop off, then the video will be uploaded at some point, but please keep going. But I think we're gonna have to draw a line at some point.
Yeah, sure. No, cool. No one is allowed to jump off. This is, you have to be here. You signed up for it, so you better get your money's worth. Oh, it is free. Okay, cool. So we saw here how I had a topic called card auth. So it's card authentication, authorization. So we'll come back to that slide where we said possible fraud during card authentication. I do have somewhere along here, I have a Kafka card publisher. So this is more or less exactly the same code as we saw before. We are creating a producer. I have a class here where I can generate. I have some random numbers. I can create a card where a card has a card ID and a date time when the authorization happens. So public class card authorization, we have card ID, auth date. We then have a static method that generates a card. So simple, naive implementation, but at least it gives us some data. In my program, I am generate a card. I'm serializing the card, and then I'm sending the message. Kafka publisher send message, and send messages basically doing what I did in that test topic, where we are saying produce async, where we are also sending in now the key, which will be the card ID. So we now have the primary key in the message being the card ID, right? Cool. So let's run this from the terminal, and we're saying .NET run. Let's see if that works. Cool. Press enter to exit. Any other key to continue? So we have generated a key card ID 1003. It has been delivered to offset 0, partition 0. That is cool. Let's create a couple of messages here. Let's go into Control Center, card auth, messages. There we go. So we have some messages sitting here. Cool, right? So that's what we saw before. Now what we want to do is, so we said that we are creating that these messages that are coming in, we can create a stream based upon those messages. Right? Because we now want to be able to handle, so instead of me reading it off from the topic in my .NET consumer, I now want ksqlDB to do cool stuff with this. Right? So let's go into ksqlDB here. We're clicking on ksqlDB application, and now I see a nice little editor here. And what I can do is I want to create a stream that I call card auth. I hope you can see this. I call it card auth. Has card ID and it has an authorization date. We are using the Kafka topic card auth, and the format of the message value is JSON. Right. We say run query. We have created now this stream. So let's go into the stream here and have a look at it. And we can say query stream. And what you see now is, so that then select star from card auth, emit changes. So that says continue to query this stream. And when you are querying it, push out the changes that happens in this stream, right? So if I now were to, so the query is now running. If I go back into my into here, and if you wonder why I'm not getting any data coming back just yet, the auto offset reset is set to latest. So it only handles new data coming in, if that makes sense. So if I were to generate some more messages here, I hope, and I hope that you just saw how a message now popped into here from my select. Right, cool. So now we have done select against these against this stream. Now what I now can do is I can now create from this stream, by using ksqlDB and SQL syntax, I can now create a table where I can select from the stream. So let's stop that query. I can select from the, so let's do this. So what we're saying, we are creating a table that we call TB possible fraud. You have to excuse me, I'm an old guy, and when we are creating, in my day, when we developed for the DB, when we create a table, we always prefixed it with TB underscore. So I'm continuing doing that. So anyway, so we're selecting here now. So we're saying create a table as select card ID, count star as number of authentications from card auth, where we're having a tumbling window for 60 seconds. So a card ID comes in, and during 60 seconds, we are now counting how many times this particular ID pops up. And if we are having a count more greater than 2, or rather we are capturing where we're having a count greater than 2. Yeah. And that is now saying that this is our fraud. That is now a potential fraud. Cool. So let's create a table. That's good. We can click here on tables, and we now see my TB possible fraud. And let's say query table. So now we're having a select statement, select star from TB possible fraud, emit changes. And let's see if this is going to work. Sometimes it does, sometimes it does not. Anyway, maybe the demo gods are with me. So now we are creating here a card ID of 1002. So we have now started this this query. 1004, 1003, 1003, 1003, and I should. Come on. And here now, it takes a while to warm up. And here now we can see that this query here, select from possible fraud, is now outputting this particular card. Right. So what can I, so that's cool, Niels, that's awesome, but what do you do, what can you now do with this? Well, if we are, when we are creating a table, like my table here, if we're looking at topics, I now have an underlying topic has been automatically created for me. And if I go into the topic, that we can now see that my possible fraud card is in here with a key and which is the card ID and a how many times it has appeared. And now then, right? And I won't do this here and now because we are so much out of time, but now then, we can now use our knowledge from .NET and from .NET consumers to have a client, to have a consumer that consumes from this topic and is doing things based upon this possible fraud, if that makes sense. Cool. So, and that's kind of it. Yeah. So, Kafka is a distributed streaming platform. We have talked about topics, partitions, offsets, consumer groups. The .NET client is on par with the Java Scala client. And when we're doing stream processing, we are handling the messages, the events that appears in Kafka. And by ksqlDB is lowering the barrier. We can, if you know a little bit SQL, you can write stream processing applications quite easily. And Kafka and its underlying plumbing takes care of most of it for you. And then when you have now your card or your potential fraud, well, you're consuming that from your .NET client, and you may now, okay, ooh, I got the potential fraud here, let's lock that card. And that, my friends, is it. Thanks. Thank you. Any questions? And I do apologize for having gone over time.
Yeah, thanks very much for that talk. It's good to see the .NET client has moved on a lot in the last 4 years, and there's a nice user interface to Kafka itself, which is, I don't think they used to be. We used to be command line. Has anyone got any questions they'd like to ask Neil before we close this evening? put them in the chat or just shout them out. Niels, if you want to post your slides and code, and I can put something in the meetup group so people can have a look at that and retweet it.
Absolutely. So what I'll do is, how's it, Adrian? I can see a lot of very different to what I thought it was going into the talk. So what did you think it would be going into the talk?
Are you putting on the spot there?
Okay, so yes, so what I'll do, John, I'll clean up this stuff here, and I can actually zip it up and email it to you, or give me somewhere where I can upload it to, and I'll share out everything. I do have actually a client. I have coded up a client to consume from this fraud topic, that TB potential fraud or whatever I call it. So you can just run it and see for yourself. In here I also have a Docker compose, so you don't need to, you just need to have Docker installed and do Docker compose up and off you go.
All right, great, fantastic. I can't see any more questions, so I think we'll leave it there. Thank you very much, Niels, for joining us from South Africa. That's setting in new records for distance presentations. Thank you, Niels. Thank you. Thank you.
Cool. Thank you, guys. Have a good evening, and I hope that the weather in both in Leeds and Scotland is getting better. Yeah. I guess you would like the weather I have here at the moment, which is frighteningly cold.
Yeah,
just
we like
22, just 22 degrees.
Oh, man.
Right. All right, guys. Thank you so much. It's been a pleasure. Cheers. Bye.
Good evening. Bye.